It's not very often that I get powered subwoofers in my shop for repair. This is a Velodyne CHT series. It's one of their smaller models, and I think it's 10 or 11 years old. It definitely has a lot of dust on the outside of the cabinet. In fact, you can see on the front grille, you can tell exactly where each of the plastic support bars is behind the cloth because the dust has filled in the spaces. And as small as this thing is, it definitely has a lot of weight to it. I had a hard time bringing this downstairs, trying to kind of carry it on my shoulder with one hand. And I want to know how much this thing weighs when I get it up here on the workbench. Put it on a scale and find out just out of curiosity. Well, I managed to lift this thing up here. I weighed it on my shipping scale and it was almost 40 pounds. It doesn't seem like much, but when you're kind of out of shape and sick with a cold like I am, it sure feels like a lot more than 40. Here's a better look at the back of it. It was made in October 9th, 2003. Speaker level inputs and outputs. Line level input and output, and a few different adjustments. Let's see. Man, this thing's got a lot of dust on it. I want to say they were using this in a garage or something, or in a pole barn maybe. It's an 8-inch driver. Foam still feels nice and fresh, so I don't have to worry about that. No voice coil rub. So hopefully this is just going to be a amplifier or power supply repair to get this thing back up and running. It's got a slotted port design. Ooh, man, that's full of dust. Well, let's have a look inside this thing, shall we? Here's a look at the inside of the cabinet with the amp module removed. I thought for sure that this would come out with the module, but it did not. I think it's glued in. So I ended up having to take out the 4 screws that hold this plastic cover over the amp assembly. And then there's one zip tie that you have to cut, 2 spade lugs to pull off, and then that zip tie was actually around this cable here. So this is kind of glued on. I didn't want to try pulling that off of there if I didn't have to. There's definitely not a lot in here. I'm glad to see that it is a discrete transistor output on here. It looks like there's only one pair of output transistors though. Probably less than 200 watts power. In fact, I'd say it's probably around 100. I haven't even looked up the spec sheet on this thing yet. It has Capson brand capacitors in it. Yeah, I need to bring my ESR meter home because I'm probably going to need to check all these. I never actually did try plugging this in, but nonetheless, I know it's going to need some maintenance. So let me unwind this power cord and see if this thing, see what it does anyway. Well, I did a quick test and power LED comes on, but there's no safety relay click and no output. So basically the lights are on but nobody's home. First thing I'm going to do is check and see if there's any DC at the input side of the speaker relay, and that'll tell me if I have something wrong with the output section or something possibly farther down. This has Sanken output transistors. In fact, I think they're the same ones that are used in a lot of Sony receivers. The 2SA1386 and 2SC3519. I know I've seen those before. In fact, I might even have a pair of those in stock. I don't have my tools with me today. I got to bring those home from work and dig into this a bit more. Well, since I don't have my whole toolbox here with me until the end of the week when I bring it home from work, I used my shop meter to do a couple of quick tests, and there is 1.4 volts of DC offset coming into the speaker relay. And that explains why the safety circuit is not energizing. So I've got to remove the preamp board to gain access to the bottom of this board to start checking all the components. But I think I'm going to put this on hold until Friday night when I bring the rest of my tools home, and we'll go from there. Well, I did find one capacitor that was out of tolerance, and it didn't fix the problem. But I did notice, after moving everything around and kind of cleaning the back of the board off and seeing it under a different angle of light, that there was a lot of cracked solder joints, and they were broken in the same way as the board in that Harman Kardon amplifier I worked on a while back, where there's like a little circle break on the entire joint. And after resoldering about 15 or 20 of them, I think I've got some operation here. I heard the relay click, so might be good to go now. I'm going to go back through and double check again, because I had gone through and resoldered a bunch of these a few days ago, looking very closely at it, and I came home today, about a week later, and pulled it out and just glanced at it and saw some more that were cracked, and after I resoldered that, then it came back to life. So I guess I've just got to keep staring at it and giving my eyes a rest once in a while, because I always seem to miss a few. But it makes sense. I mean, this board is mounted on edge right on the main plate of the amplifier, so it's subject to all that vibration. Strangely enough, the preamp board doesn't seem to be affected by the same problem, but it's probably because it's not mounted quite as rigidly. So let me go back through this and we'll put it back together and see what it does. Well, it's running, but it seems awfully weak to me. I'm going to turn it up just a little bit and it cuts the protection relay. I got to power cycle it. Oop, too high. So I'm going to pull the amp module back out and do a load test on it. Make sure it's running at specifications, because it seems like it should be a lot more powerful than that. Take all these darn screws back out. Just like I suspected, this thing is not performing to specifications. It's cutting off at around 60 watts, about half of what it's rated for. And the funny thing is, there's no sign of distortion. Signal is perfectly clean right up until it cuts off, so I'm not sure what's going on, and it's very hard to troubleshoot this thing without a schematic, and also with the fact that the board is not silk screened on the back, it's hard to trace things like that. I'm doing a bit more troubleshooting here, and I decided to check the DC voltages that feed the op amps, which is typically plus and minus 15 volts. And these are 4558 op amps, and according to the data sheet, the limits are plus and minus 18 volts. The negative rail is running at almost 20 on this, where the positive is at 14.8, right about where it's supposed to be. So I think the negative rail is out of regulation, and unfortunately I'm going to have to detach this board from the frame so I can see what the components are here. After removing the power transformer so I could get a better look at the board, I see that there's a lot of that nasty brown glue all over the components in that regulator section, and I wouldn't be surprised if that glue has gone a little bit conductive and caused that transistor to conduct a little bit more, throwing the regulator a few volts out of tolerance. And at this point, I'm already putting more labor time into it than this thing is worth, so I'm just going to have to ignore it from here on out, because I'm doing this for my own curiosity at this point, and I'll make a video about it. Maybe it'll help somebody else fix one of these in the future, or even myself if I get another one of these coming in with the same symptoms. The biggest problem I see here is that I'm going to have to sacrifice this silicone thermal pad that's installed down here, because these are a one-time use. So probably what I'll end up doing is replacing it with individual pads on each of the transistors when I put it back together. But I just want to see what's wrong with this thing, so let me finish taking it apart. Here's a closer look at the board, and there's definitely a a couple small components underneath some heavily discolored glue right between those heat sinks. And this capacitor right here is the one that I replaced, but I'm going to double check all these other ones around these heat sinks too and make sure they're within tolerance, since I've got this all taken apart. It's going to be fun trying to clean that glue out of there. I'm probably going to have to remove these heat sinks altogether, get them out of the way so I can access that better. Just as I suspected, that glue was all over a part of the board where there's a little diode down here. I'm assuming it's a 15 volt Zener diode looking at this circuit, but I won't know until I unsolder that and try to read numbers off of it. That diode is all corroded, and that feeds into the base of Q802, which I've removed. That is a tip 30B transistor, and that is what feeds the negative voltage to the op amps. And based on my experience, most op amp circuits like this run at plus and minus 15 volts, and seeing that the positive side was at 14.8, I think it's a pretty good assumption. So that diode down there is probably the reference voltage for that transistor, and more than likely it's bad. It's corroded, so I'm going to have to change it either way. But I'm going to go ahead and remove that and see if I can find what number that is. I really wish I had a schematic for this, but it's kind of fun tracing stuff down without a print sometimes, at least when I have the time to do it, but it's definitely a lot more work than just simply looking at a print and saying, oh, this voltage should be here, and this is what this part is, and so on and so forth. Alright, looking good. I replaced that diode with a, what is this part? A BZX85B15. A little bit overkill because it's a 1.3 watt, but that's what I had in stock. So that was indeed a 15 volt Zener. I've put that all back in and tested the voltages, and they are right on 14.8 on both sides. So I think it's going to be good to go at this point. I'm going to put it back on the plate and temporarily run it even with the old thermal interface just to see how it performs, and do the final reassembly once I have new thermal pads. Much better. I can turn it up all the way without it cutting out. It just self-limits. Got lots of air noise from the screw holes being open in the back. But it's working. Just got to properly reassemble it and take care of that thermal pad, and I think we are good to go. Lots of air noise. Sweet. Well, one more project, one more mystery solved. Alright, I'm just about finished up with this board. I changed out that 6.8K quarter watt resistor down there that was all corroded, and those other three small capacitors that were next to these heat sinks, since they were exposed to all that high temperature and corrosive glue for a long time. I wanted to get those changed while I had it apart. I've also got the new thermal pads installed in all the transistors, so that's all set. I think I'm ready to put the transformer back on and give this another power test. Well, this amplifier is a little bit underpowered. It's rated for 130 watts, and I found that I only get about 112 watts out of it unloaded, and then loaded at 8 ohms it goes down to about 80 watts before the limiting kicks in. And it seems to limit itself right around 28 volts or so, 27, 28 volts into 8 ohms. It's a little bit on the weak side, but I think it's functioning correctly now at least. It's not cutting off even at full volume. So I'm going to go ahead and put this thing back together, see how it sounds. Oh, it appears to be working just fine. It definitely has an internal crossover because I'm only getting the higher frequencies through the amplifier now. I'm actually using the preamp out and main amp inputs on this Marantz, running at line level here. Yeah, she kicks pretty good. I'm going to clean this cabinet up a bit and call this one finished because I am really out of time. I wanted to test the enclosure in the driver with my speaker analyzer program and see what it was tuned to and everything, but there's just not enough hours in the day, and I got to get this thing out of my workshop, move on to the next project. It's kind of nice having this old Marantz 1030 back out again after so long. It works perfect for testing this. Here's what the song is, if you're wondering. It's called Our World by Archie, one of my favorite electronic musicians. And this darn RCA cable's got a bad connection up here too. I keep losing my right channel. But anyway, I'm going to move on from this, so I'm going to go ahead and put this video together, and hopefully I got all the information in there that I wanted to get in. It's kind of tough doing these on a work night and trying to rush through it without missing anything, but there you have it.